I was a little bit worried when Barry asked me to present, and you'll realise over the next sort of 40, 50 minutes why. Because I wasn't really sure what to present. I was even more worried when, having said yes, that I was told I was making 2 presentations, one today and one tomorrow. And I thought, well, I'm just not capable of doing 2 entirely different presentations. So if you go to sleep during a period of this lecture, which is highly likely, don't despair. You might be able to catch up a little bit tomorrow. I'm going to try and make them a little bit different. The other worry that I had, though, was the sort of title. Barry said, applications where power electronics makes a difference. Go on, go and tell everybody about the areas of technology, you know, that people are actually going to go and be going and making a difference in during their careers. I don't know that I'm capable of doing that, really. And I'm going to try and, through this presentation, explain why I think I'm totally incapable of making that presentation. So I had a bit of I thought, let's do a different presentation. And I thought immediately, let's do something on, you know, power electronics. We all know in this room, and interestingly, more and more people outside of this room, more and more people outside of power electronics, outside of electrical engineering, outside of engineering, are starting to recognise the impact of power electronics and the ability of power electronics to actually save the world. But unfortunately, I'm not wearing sandals, so I didn't think that this was really the appropriate title. And then I sort of stumbled on, what about unlimited opportunities? Because I think that, you know, when we think about power electronics, I'm increasingly coming across new and new areas where power electronics is being used today, but many, many more areas where power electronics can be the solution to the future. And in areas of industry and areas of life where people have never heard about power electronics, people coming from a power electronics background can actually see, hey, but we could do something. We have some technologies that we know about, maybe being applied in different areas, maybe it's from being applied in, say, automotive, that could be applied in aerospace, things that are applied in industrial drives that could be applied in your domestic washing machines. So there's huge spreads of applications. So I sort of stuck on this kind of area. I thought I'd also show this. This is it's just a Dilbert clip that my daughter sent me. Because she keeps telling me that I'm constantly trying to tell her how things, if she just did things in a different way, things would be so much better. And I think that's almost the trait of an engineer. And it's a trait of, you know, what you guys, as you go through your careers, have got to do. And it's really tough because you get grey-haired old guys who are in senior positions in organisations, laying down tablets of stone, laying down processes that you've got to be to follow in order to do certain things within organisations. And I suppose the message from my presentation is you guys have got to be there to go and break some of those molds. And I wanted to give you a little bit of an insight as to maybe how some of those molds developed. So what I was actually looking was, yeah, we're going to look at some applications, not in any great depth, don't get too concerned. There'll be no Laplace transforms or anything of that nature. There'll be, I think I get through this without a single equation, so it'll be fairly light relief. I'm going to talk a little bit about innovation and a little bit more about this era of opportunity. And it is opportunity. You know, Barry said in his introduction, you know, that there is a great shortage of engineers. And because of the growth of power electronics, this is going to be, or is an area where there is a tremendous shortage, and it certainly isn't a UK problem. It's a problem in the UK, but this is a global issue. Some countries are taking the issue or grasping the opportunities more seriously than others, but it is a general global issue. So applications, trying to put power electronics into a bit of perspective. This is just you don't try and read all this stuff at the bottom. This is actually not power electronics just, it is the electronics industry in the UK. And for one of the few times I'm going to be a little bit UK centric. You know, I think it's very dangerous to think about any of these markets just from a national perspective, because everything is really global. But I just thought it would be interesting for people to say that we have 850,000 people working in electronics in the UK. That's a lot of people. What's even more interesting is quite a lot of them are actually making things. On the radio this morning, coming across to this event, I heard a guy talking. He works for, I think, XYZ Machine Tools, and he was talking about the manufacturing industry in the UK, and they're all old men. Oh, what a depressing thing for somebody who is running an engineering company to say. And it is so wrong. He needs to get out and see the amount of equipment that is being manufactured, the amount of components. I think from a UK perspective, everybody thinks, well, all ICs are made elsewhere. Not true. There is a huge amount of manufacturing in this country. But also the contribution to the economy, 40 billion. From the electronics industry. And this is an interesting figure. 5.4% of gross domestic product. So it's how much the country earns. You could say it's the added value that we put onto equipment. That's quite a big chunk, really. Don't want to talk too much, but they are growing quickly, 7.1% growth. So the electronics industry is growing as a proportion quite quickly in the UK. So it is a major employer. We're going to talk a little bit more about that. It's involved in a whole diversity of different areas. And from a power electronics perspective, I think one thing since I changed my role from being technical director of a company in one little area, I thought I knew what was going on in the power electronics industry generally. I now realise I just didn't have a clue. There is such diversity of application and such a diversity of opportunity. I mentioned before the danger of looking at things from a national perspective. It's from a global perspective. The power electronics market is big, £135 billion and growing quickly. We can argue all we want about that figure. It fluctuates, but I can only see, looking at some of the really exciting areas where power electronics is only just being recognised as being able to make a major contribution, that figure is going to grow enormously. It's a very competitive, highly competitive market. Just about every sector there are multiple companies competing on price, competing on technology. Rate of innovation is generally very, very fast. Interestingly, taking a local view in a global market, the UK is actually competitive in a number of areas. And just looking at a few of them, aerospace, automotive, we're going to hear from Roger Thornton this afternoon in this area, industrial drives of all sorts, renewable energy, HVDC, big areas, and many, many more. And some of them would be very surprising. And that's in the systems area, in the component area. It's very, very interesting, the contribution that the UK makes, both in manufacturing as well as in design. Just in the UK, we actually manufacture more than £4 billion pounds worth of power electronic product, not the components, the actual systems products. And that's just the power electronics element. When you add the bit that power electronics is enabled, it's probably worth more than 40 billion to the economy of the country. It's big, it's important. But until recently, a lot of people had never actually heard of the word power electronics. We have a pretty good international reputation for design in certain sectors. And a particular recognition for design for global manufacture. There's a lot of manufacturing done in this country, but there's a lot of design that's done in this country for manufacture in entirety or part overseas. And that's not a bad thing. That's not a bad thing. We've got a very strong SME base. Lots of smaller companies who are feeding through components into the brand names that you will all have heard of. But it's not just the components. A lot of the smaller companies are driving innovation. And innovation is something that at a postgraduate conference should be in your thoughts. It's part of your remit. Part of your training in doing a postgraduate degree is to, I think, unleash the ability to drive innovation. And thinking back to the UK, we've got good routes to market. Just some of the big names, and I think we could put hundreds of names up here. There's the big sort of system names. You always put Rolls-Royce on a UK manufacturing thing because it's a wonderful logo. Wouldn't look right on my car, but it's a great logo. A lot of the big global players are here, GE, increasingly so. Isn't it interesting? I've done that slide with GE and Siemens hovering around Alstom. But I think that deal's now being done. But other companies who are present, International Rectifier, making power semiconductors in the UK. And they're making enormous numbers of semiconductors. Hang around tomorrow, because I've got some numbers tomorrow that I'll talk about there. But a lot of major companies in different areas. IQE, substrates, leading substrate design and manufacturing based in the UK. The universities that you guys are attending are amongst some of the best in the world. A lot of them are really very highly respected in their own rights, highly respected in the areas of engineering, the different disciplines that make up what is a power electronics engineer, but very much respected in the research, the teaching that they do in the area of power electronics in all its guises. So your background in doing a postgraduate degree at UK universities, and this is just a sample, please, no hate mail, because I didn't include the University of the... I used to put a grey blob with other universities, or your university, underneath, and then somebody said, that was a real insult to put a grey blob for my university. So you can't win. But this is just a representation of some that are involved. What a foundation this is for a number of things. Great for the UK, great for UK industry, but great for the students. And I think one of the exciting things about this conference is, one, hopefully there will be more opportunity for you to meet other fellow students from other universities. And I think that's important. And it's important that you maintain those links. You're going to keep coming across each other. I had a discussion, Barry, I and Roger Thornton, we said, you know, we haven't actually met together since, what, 1982, did you say? We met each other separately. And, you know, been a lot of contacts that you develop at events like this that will be important going forward. Power electronics is everywhere. I steal this from Nottingham Uni, but I think it's a lovely, lovely little logo. That.
You stole it from Intel, so.
Did we? Well, yes. It is a slightly different swish, and it's slightly different, but it's. Yeah, I think it sums it up, and it sums up the role, and it also explains why power electronics has not been that well known. It is embedded in other things, but wow, it's embedded in just about everything. You know, and these are just a selection of areas. But it's interesting how it's transformative. It really can change the picture of whole industries. You know, the obvious one, which I'm not going to go into any great detail, is you'd think about automotive. Roger's going to talk about that this afternoon. But how power electronics, or how electric vehicles are really transforming a whole industry, scarily for the people who are actually in that industry. And it's happening in a number of different groups. I'm going to talk about just a few areas, very, very superficially really, but aerospace, massive, massive industry in the UK. When I was in my industrial drives bubble, I used to be really upset about how much subsidy, how many grants were given to the aerospace industry on the basis that it wasn't very big. Why are we investing so much in it? But it's huge, and the UK is really, really good at this. In the aerospace industry, the UK is the second largest electrical equipment manufacturer in the world, behind the US. It's as big as France and Germany put together. It is a massive contributor to our gross domestic product. It's a massive contributor to the technology in the country. Don't have to read all of this, but it's Big Boss at Boeing back in 2005 basically saying that make your power electronics small enough and it's going to transform the industry. And it's getting power electronics equipment, we know, is getting smaller, lighter. Jeff's going to touch on wide bandgap devices and the impact that they're going to have in helping this kind of innovation come along. This is quite big. And if we can use electrical power, electrical energy transformation within aircraft, the effect is going to be quite dramatic. Conventional aircraft have all sorts of control. They take bleed air for various functions like the environmental control, like de-icing, big hydraulic systems doing things like all the actuation on the wings and so forth. About 175 kVA of electrical equipment on a typical plane. The move to more electric, and we're not changing the propulsion to electric, don't worry about that. But this is big. This is a lot of power electronics, because a lot of that is going to be converted in some form or another. A lot of functions becoming electric. There's a lot of engineering in this. We all want to be safe when we're here, so a lot of emphasis on reliability, robustness to very extreme environments, and so forth. And a lot of the technology that is involved here can be applied elsewhere as well. But this is an industry going from, that's been having about 175 kVA of power conversion, very limited number of components or functions within the plane, to whole planes. So what's the impact of this on the need for power electronic engineers? It's enormous. I'm not going to go into any further depth on that, but it is just great. And power electronic or aviation is massive. You know, adding about 1,000 new jobs by 2015. Another 4,000 jobs, but every job has massive value associated with it. Everybody working in the automotive industry contributes about almost £250,000. That makes them quite valuable. The company should be investing in them and looking after them. So automotive's, I think, one interesting area. This is an area that I find really scary. And I find it scary for a lot of reasons. One of them being the people that I talk to who work in this industry, which is not to put you off off it. It's not been, if you think about, and I'm thinking here, not about a power station, I'm thinking about the transmission from the power station and the distribution, localized distribution. It's not an area where traditionally there's been a great deal of power electronics. There has been on particular industrial sites or particular installations, you know, things like mining, where maybe you've got long cables going from the surface underground, you want some automated tap changes. The sexy ones have had power electronics involved in them. But beyond that kind of thing, power electronics hasn't really featured greatly. I always find this a fascinating picture, because working in power electronics, working in electrical engineering, you get obsessed with electrical energy. You tend to forget that there are other forms of energy. And DEC, the Department for Energy and Climate Change in the UK, produced this. They used to produce it annually, but it got to 2011 and I think they got a bit scared. So I've not seen one more recent than this. But it shows the proportion of electrical energy. It comes here from natural resources, you know, the gas reserves coming in, coal, electricity, which will be for things like renewables, solar, well, as a renewable, bioenergy, petrol, oil, coming through transformations, coal going through power stations, and out comes this pink bit, which is electrical energy for consumption in domestic, down here, industry, and others. So you can see in here that electrical's important, but wow, it's 18% of the final consumption of energy in this country is electrical energy. Only 18%. If we've got an energy crisis, why bother about electrical? If you look at this, you know, let's put our focus on these other areas. And we are putting a lot of focus on a lot of these other areas. If you look at things like oil, we're looking at how we can burn things more efficiently and do a whole host of things. What's inevitable, though, is that the proportion, this 18%, is going to grow. It has got to grow. A lot of the stuff we're doing with oil and gas is converting to electrical energy because we can manage that electrical energy more efficiently, more and more. And we can manage it through what? Well, power electronics is one big area. So I think it's an interesting chart just to think about. When we are talking about energy crisis, think there's more to it than just electrical. Yeah. And how are we going to move electrical into a number of the other sort of end uses? This I find a depressing slide. This is the spend in the UK, and it's not, I wouldn't say it's mirrored exactly around the world, but it's not a totally unusual picture. When we look at the spend of R&D on energy, the definition of energy here is really the power industry, power generation, distribution, transmission. And a lot of it is related to generation. You can see the huge spend that we had in nuclear, which is really sort of distorting the overall picture. But just look how the spend on R&D into energy just collapsed. And we've been doing not very much. We had a bit of a panic. If you go back into sort of 2008, 2009, there were things on the news that we're running out of energy and there's going to be an energy crisis. So, you know, there was a little bit of resurgence, a lot of that under the guise of energy efficiency and what we're going to, how can we make things more efficient. But the overall spend, well, it peaked and it's gone back down again. The industry here has not been spending a great deal on R&D, and it's got consequences. You know, my concern is I think that the lights really could go out, and more than that, they have gone out. In April, the north of Scotland grid collapsed completely, and people in south of the border aren't that bothered about what happens up there as long as they vote in the right way. So we don't know about this. The even scarier thing is they don't know what went wrong. Lots of things have been suggested as to what happened, what might have caused it, but the truth of it, speaking to a number of people who were involved, they just don't know. They really don't know quite what happened. More scary, they don't know why it didn't take the whole grid down. They're not that certain why it actually stopped and was restricted to a north of Scotland issue. So I'm sort of, don't go away, you know, I must remember to charge my computer before I go to sleep because there may be, you know, nothing in the plug, in the socket tomorrow. Don't panic too much about it. But it to me shows an example of vulnerability. Renewables, which are the saviour for everybody, are causing huge problems. Huge problems. We have a distribution system that wasn't designed to have generation dotted all over the place. And not only is it the capacity of the cabling, it's the protection. A lot of the protection on the network only works with energy flow in one direction. So we start somebody sticking a wind farm on somewhere in the, let's pick on Wales this time, somewhere in the Welsh Hills, we can suddenly get some real issues. Protection is an issue, as I say. System stability can be an issue. We got some great research going on associated with some of these things. But it is and can be a problem. And it can be a problem in the most unsurprising areas. You know, I find people joking about, hey, with solar, all we need is a group of neighbours to suddenly decide that solar cells are a great idea, stick them on the roof down a whole road, and suddenly we've got a bit of a local problem. Well, it happens, and it's not often the neighbours who are getting together, it's the council who decide that they're going to put them on council-owned housing. So they do complete districts, end up with some real problems of stability in the network, problems with protection, problems with voltage control. If you think about these things, they're all things that power electronics engineers look at and deal with on a very regular basis in different areas. We're forever controlling voltage. We tend to be pretty good at dynamic control. We're pretty good at understanding protection. How can we protect things? It's an area where we can have huge impact. We can make things a lot worse. You've talked about solar cells, electric vehicle charging. You know, that's something that people have never considered when designing a network. Could be, I'm a bit emotive. You know, again, don't worry. But it's presenting some real challenges. And this EV loading, power electronics, you can argue, causing the problem. We've got all the charging and so forth, but we can be part of the solution as well. But it needs a clear understanding. Another one I've stolen from Nottingham. Do you guys do anything other than draw nice pictures?
No.
That's all right then.
That's very old.
Yeah, but it's a good one. Some of the old things can be good. Doesn't always happen with people though. We've talked about smart grids, and I've been to so many seminars, read so many papers where I've read that smart grid is a communications network. The government has given tons and tons of money under the smart grid banner to solve the problems of the world, and it turns out it's communications, and it's important. Communications, we need to be able to communicate from these different devices. We need to know what's going on. We need to be able to monitor what's going on in the networks. At the moment, we can't. At the moment, we have very little idea what's happening on the network other than whether particular breakers might be closed. We don't actually know what's happening on loads and so forth. So we need to have communication. But knowing about something and being able to do something about it are two different things. And power electronics is going to appear in a whole host of different areas in order to provide the control that the communication guys are providing the raw data for. Communications is important. Please don't go back and say Bill Drury thinks communication is useless. I'm going to come back to that in a second. But really, power electronics, if there's one industry, no, there's many industries, but you think of the opportunities in here. All of these beautiful orange blobs are bits of power electronic equipment. And I would say almost, well, no, maybe I should look at the posters first. But almost everything that you guys are going to be working on could have some relevance in these areas. And I'll make a particular mention for energy storage. That's something we keep talking about a lot, but that's a massive, massive area, but without enough time to go into. I thought this is an interesting slide that comes again from the Department of Energy and Climate Control. And this is a UK thing. So having made a big point about how, forget the UK, everything's global. But it is interesting just to look at the amount of connected capacity of renewable energy. We've actually got 14, well, when was this taken? It can't be long ago. I've stolen this from somebody else's presentation that was made in March. So around March time, 14 gigawatts of capacity of renewable energy connected in the UK. That's about 28% of the UK's grid capacity. Clearly, the nature of renewable, it's not always there. It's not, can't be called up for most instances. So don't suddenly think Bill Drury said 28% of our energy is being generated from renewables. Not true. But that's the installed capacity. There's another nearly 4 gigawatts being constructed. There's another 13 gigawatts, almost as much again, which has been approved, waiting to go in. And there's applications to put in another 20 gigawatts of renewable energy into the UK. 52 gigawatts capacity. You can add those percentages up. I should have done that. But it's an awful lot. It's an awful lot. And that doesn't include the solar cells or the little windmill that you've got down at the bottom of your garden. These, I forgot what you call it. I can't remember what the acronym FIT is. But there's about, it's a feed-in tariff project, that's it. There's another 1.6 gigawatts of these that are already installed. Problem is, the distribution system can't cope. There is some of this capacity that they're going to build, they've got permission, they're not going to be able to connect. There's a whole pile of it because of protection and the actual infrastructure of the distribution system. So there's an awful lot of renewables that are out there. And I think, can I think of a renewable source that doesn't involve power electronics? Don't know. So if I go back, and I can go back a long way, but if I go back not too far, renewables were a bit of a Cinderella activity. You know, if you were involved in wind energy, you know, you really did have to have the correct footwear. You were considered a little bit odd. Not so today. Not so today, but yeah, it's happening in a big way, but there's issues within the distribution system.
Bill, I'm sure half the audience has done this, but when you add that up, it comes to 101%.
But it's not there all the time. That's the problem. And it's why this is important. You know, energy storage. You know, it's the eureka. It's what everybody seems to be talking about. If only we could efficiently store energy. You know, and there's all sorts of things being talked about. You know, doesn't it seem so obvious to an electrical engineer in particular that we use all these batteries in electric vehicles as our storage point? You know, they're just going to sit there. The wife won't use the car all the time. Massive problems associated with that kind of stuff. But it's a massive, massive market. 220 billion by 2021 for the energy storage market. Okay, that's whether you believe market research or not. If it's a factor of 10 out, if it's a factor of 100 out, or no, factor of 10 out, it's still a massive, massive number. energy storage, battery management, centrifuges, just about every system of energy storage, opportunities for power electronics. I thought I'd put this up. This isn't an actual picture, but this was the model of my very first car.
Nice colour.
It was fabulous. It cost me £300 and it had a radio. The radio was quite important. Well, it had a radio to start with, but it got stolen. But the point of this is, one, that I saw the picture of the car and I sort of thought, a bit of nostalgia, memories of happy times. I first drove to meet my wife in. It was such a special car. But it was full of rust. The engine made very strange noises after a relatively short period of time. The windows never really went up and down properly. It was not a great car. In those days, cars didn't last. Some of you might need a translation for what is rust. You know, cars used to just literally fall apart. This one, when I parted company with it, was certainly very close to falling apart. But the changes that have happened in the automotive industry, so many of them are visible to us all. You know, that we look at a modern car and, you know, they don't fall apart in quite the same way. They last for an awful lot longer. The windows tend to work. The engine tends to work often without noises or horrendous noises coming from them. What's even more worrying is, I shouldn't say more, because Roger's going to talk about this, except I have a bit of a bitch with Roger because my son works with Roger at Ricardo, and he comes out with sexy things that he talks to his mother about. And this apparently is my wife's next car. And it's a Golf GTE, which will be launched in August. Hybrid, plug-in hybrid. It's unbelievable the technology that's in here. It's unbelievable the performance. It's unbelievable that I haven't been able to persuade my wife that no, this isn't the car that she can dream of for her next thing. But a lot of what's happened in this area is driven by power electronics, electrical machines, power electronics in terms of, you know, not associated with machines as well. Very, very exciting area to be in. But as I say, Roger's going to talk about that. I thought I'd finish off really by talking a little bit about innovation. We all see the sort of the Moore's law, logarithmic calendar, how processing power is getting more and more. We see the same kinds of things for, you know, IGBTs getting more and more efficient, and this is all before you know, Jeff's going to come and tell us, well, beyond that we move to wide bandgap and new devices. But there's massive, massive changes, and they are huge changes. And we've got to be thinking now, if I look back, as I'm going to do a little bit more reminiscing, of the need to accelerate innovation. And I think if I leave you with a message, it is that you've got to do that. Your generation, more than any other, has really got to accelerate innovation at rates beyond anything that we have dreamt of, which frankly is why I found it difficult to do the presentation that Barry asked me to do. Because I find it difficult to be projecting 20 years ahead, to be thinking, you know, what is it I can talk a little bit about some of the problems that we can foresee today, but to think what's going to happen in 20 years. If I can think of it, you guys have failed. That's what I think of you. I just wanted to talk about some of the basic tools you've got at your disposal. Yeah. The computer and the cloud in all its manifestations. You have so many tools at your disposal to solve the problems. This is just a metaphor for all the simulation tools you've got, access to data. If I go back, and this is real. This is my engineering tool. If I had any sums to do, that's what I would use. If I had a small sum to do, I could use a small one. And you know, I kept that in my car to work out miles per gallon on that earlier car. How sad is that?
Pretty sponsored, quality.
No. But that, can you imagine it? We were allowed to take these into exams, some exams. When we had really difficult or we needed ultra precision, the idea of going to a bigger slide rule wasn't there, but we had these things. I wonder if many of you have heard of log tables. And we could do sums to 4 decimal places. Multiplication, we could divide, we could do wondrous things. And there were even tables for logs of sines and logs of time. We had to struggle with this sort of crap. Think what you've got. The textbook, to show it's real. This was the Bible. When I got one of these, this would tell me everything about how I needed, or what I needed to do to design a bit of power electronics kit. If I had to design a snubber circuit, if I had to look at a gate drive, if I had to series devices, which you used to have to do an awful lot because they didn't have high voltage devices like they had before. There's a complete story of EMI. And we had to produce and innovate using basic kit like this. It's just so easy now. And we did this, sort of moving in an industrial drives area. You know, we've gone from products that look like this to things 70% lower volume, cost down by at least that much. But there are things like reliability and functionality have just gone completely through the roof. You know, there's been such a transformation between here, where to think about the next generation product, think about how do we improve things, a little incremental shift would be okay. You're on a path. You know, if you could introduce an LED into this that would allow somebody to find a fault a little bit quicker, that was good. You know, you could almost get a half-page article. You could almost get a publication out of something like that. Totally different world now. It's just not enough. This is as I get older, I start doing really stupid things. I read a psychology book. It's been the most difficult book I've had to read. It's quite a popular one, Thinking Fast and Slow. And I've just got to the conclusions, and I'm just building up to read the conclusions. But they introduce things like this, theory-induced blindness, where you're so set in your ways of doing things, you've been told something, and you just accept that as being a fact. and you stop questioning it. One of the hardest things I ever had to do, Phil Mellor asked me to do a first-year lecture course at Bristol, and it was the hardest thing I've ever had to do, I think, because there were so many things that were so obvious. I just knew they were right. I've been working with it for so long. Relationships in transformer equivalent circuits. Some of the work on three-phase systems. I knew it. But a lot of the things I didn't understand the fundamentals. I'd forgotten where it came from. And the same can be true in just about anything that you do. Somebody tells you something, try and understand what's the limitation, why is that right? Really be able to go back to first principles. Challenge the convention. Hey, it might get you sacked if you go and tell your boss that he doesn't know what he's doing. It might be a sort of a career hazard, but you've got to challenge things. If you don't challenge the way things have been done forever, then they'll continue to be done forever. And one thing I was always taught was try and make things better. I think this is also interesting. I'm having lots of discussions with people about what is a power electronics engineer. And is it a subset of electrical engineering? Well, not really. In my sort of little sector of industrial drives, we have electrical engineers, electronic engineers, mechanical engineers, structural engineers. These products get stuck on and shaken around. Control engineers, it goes on. Multidisciplinary teamwork is vital. And that's one thing, you're doing a PhD, you're working on your own. Yeah. Talk to people. Think outside the box. There might be people in another department that can assist. This, I think, is really interesting. Real need for cross-functional and cross-sector cooperation. But there's less and less opportunity for it. There's so many specialised conferences now. So many really specialised journals and get-together that you've got to make an effort to go and talk to people who are working in slightly different sectors. Even if you're working in power electronics, as I was, you can say, I've got other personality disorders, but I didn't go and talk to people in automotive. I didn't go and talk to people in the energy sector. It's only since I've sort of stepped out of it that I've started talking across different areas. Try and do that. Look for opportunities. I think in some respects, power electronics you can say is mature. Not in the sense of radical change can't come along. But there's still areas where people worry about reliability. But it's been achieved in a number of sectors, as an example really, and that experience, how to achieve that, can be passed on into others. A lot of stuff, for example EMC, it can vary in requirements and in the nature of it between different sectors, but the physics can't. Again, you can learn. But vocabulary can be an issue. I think it's really fascinating to think about vocabulary. One of the most important things. But the number of times I meet people and I don't know what they're talking about. I really haven't got a clue. Now, some of it is because I've just got too many grey hairs. But they're speaking a different language. I used to use training sessions for a number of project teams in industry. I used to ask them a question. What language should the objectives be written? And it's an interesting, the number of people, because I have people from all over the world, it should be English because we're English. English company, English language. And that's not the question. We need some kind of simple vision for what the overall thing is. We needed, the user of a bit of kit. What are they expecting? What are the design engineers going to have to build in? Marketing people, totally different language. Got to be really careful, but they need to understand things. Accountants, even more different language. But you've got to understand these different things, and manufacturing. And we ended up putting together totally different series of documents to address all of these different things, plus one document, a picture. This was a concept picture showing the functionality that was going to go into a new product. And we laminated that. I don't think I bothered bringing that with me. And everybody carried it with them. You wouldn't call this a detailed specification. The actual paperwork with all that other stuff, and it was in the days when it was computerized, but we printed it with all the different specs, came to, I think it was 1.1 metre of A4. Heaven knows why anybody would ever print it out. But this is an interesting one. And Jeff, don't get upset. But semiconductor suppliers and the users are often very different animals. The number of people, and so I had to look at it, find a picture of somebody looking quizzical, and I'm almost at the end. So finding a picture of Boris looking totally bemused was quite easy. But the number of times that I've had semiconductor suppliers come in and talk about, the doping and how we're going to just tweak this and we're going to... It's not what I'm interested really. That's not... I want to know what it's actually happening about. So even across sector, it's really important. But we've now got a lot of technology-driven innovation. We're going to hear about wide bandgap devices that really are here. We've been talking about silicon carbide and GaN for forever, but you can buy them. They really do exist. And lots of new high-temperature materials impacting whole other areas. It's not just a wide bandgap revolution that's going on. We've got control, which is becoming cheaper and cheaper to implement. And I'm personally fascinated by the idea of getting high performance out of really non-ideal components. New and some revitalized converter and system topologies, revitalized because new components and new control systems are enabling them to overcome some of the issues. Things like wireless, even cloud-based systems control is coming. And improving tools. And I was a little bit flippant just showing a picture of a computer, but some of the design tools are important. But this one, cross-sector leverage. Final things, in 2011 I was involved in a UK power electronics strategy that the Business for Innovation and Skills sponsored. And just a few words, just to show that power electronics is taken pretty seriously at government level and elsewhere. Since October 2011, we've established an organisation, Power Electronics UK, which is working, it's industry and academia group together, trying to promote power electronics within government. We're also coming out with some driving direction in a number of areas, skills, feeding into some of the technology paths in the centre. I'm working with the IET on a technical and professional network for power electronics machines and drives. These guys who have been the most unresponsive and boring people you could possibly meet, have certainly switched on to we want to get involved with power electronics. EPSRC, as Barry said, have committed 44 million to this centre. TSB's committed 19 million. We've got a capability directory. If you haven't seen it, look for it online, showing a number of companies who are involved in power electronics, be they SMEs or OEMs. A lot of move to coordinate skills activities across engineering, not just in power electronics. And yeah, the needs, but also the opportunities for power electronics are really quite enormous. So I'm afraid it wasn't really what Barry wanted me to talk about, but he's not flashed red lights at me or anything else. So
Well, it's been interesting.
well, that's thank you for that. Good luck.